elements. Dubernier's triads, modern periodic table, and Newland's law of octaves. Dear students, visit your school library. Observe how the books are arranged. Ask your librarian whether any particular method of classification is adopted. Now let's see how elements are classified. Matter can exist in the form of elements, compounds, and mixtures. In earlier days, few elements are known, and they are classified on the basis of their properties as metals and non-metals. But some elements show properties of metals and non-metals both. They could not be placed in both the classes. Dubernier's triads. In 1829, John Wolfgang, a Dubernier German scientist, found some groups of 3 elements which showed similar properties, and these groups were called as triads. This triads shows that the atomic mass of the metal element was approximately the mean of the atomic masses of other 2 elements. Now let us see the example of one of the triads. In the above table, take the triads of lithium, sodium, and potassium. The atomic mass of sodium, 23, is the mean of atomic masses of lithium and potassium. Similarly, we can verify the atomic masses of strontium, bromine, and selenium. The system of triads was not useful because Dubernier could identify only some triads from the elements known. Other triads did not obey Dubernier's rule. Hence, the system of triads was not useful. Newland's octaves. The next attempt to classify the elements was done by British chemist Newlands. Newlands arranged all elements in an increasing order of their atomic masses. In that, he found every 8 element had properties similar to that of first. His classification was called Newland's octaves because of its comparison to octaves found in music. Newland's law. When the elements are arranged in an increasing order of their atomic masses, the properties of the 8th element are similar to the first. Some features of Newland's table. 1. Newland could arrange elements only up to calcium out of total 56 elements known. 2. After calcium, every 8 element did not possess properties similar to that of the first. Three. At the time of Newland's, only 56 elements were known. Later on, new elements are discovered. 4. In order to fit the existing elements, Newlands placed 2 elements in same position with different properties. 5. This periodic table did not include inert, that is, noble gases, as they were not discovered. Mendeleev's periodic table. Mendeleev believed that atomic mass of element was the most fundamental property in classifying the elements. He arranged elements in the increasing order of their atomic masses and found that the chemical and physical properties of elements show repetition after certain intervals. He arranged known elements in the increasing order of their atomic masses and the horizontal rows, till he encountered an element which had properties similar to the first element. He placed this element below the first element and started the second row of element. In this manner, he could arrange all known elements according to their properties. He created a first periodic table containing 63 elements known till then. Mendeleev's periodic law. Mendeleev's periodic law states that the physical and chemical properties of elements are a periodic function of their atomic masses. Mendeleev's periodic table. The tabular arrangement of the elements based on the periodic law is called the Mendeleev's periodic table. Main features of Mendeleev's periodic table. 1. The horizontal rows in the periodic table are called periods. There are 7 periods numbered from 1 to 7. 2. Properties of elements in a particular period show regular gradation from left to right. 3. Vertical columns in the periodic table are called groups. There are 8 groups numbered from 1 to 8, containing subgroups A and B. Merits of Mendeleev's periodic table. 1. Mendeleev classified all known elements successfully. 2. He kept some blank spaces in periodic table. These vacant spaces for elements that are yet discovered. 3. After discovery of noble gases, they were placed in periodic table without disturbing the position of other elements. Now the demerits of Mendeleev's periodic table. 1. No fixed position could give to hydrogen in periodic table because hydrogen resembles alkali metals as well as halogens. 2. At certain places, an element of higher atomic mass has been placed before an element of lower mass. For example, cobalt. Co is equal to 58.93 is placed before nickel. Ni is equal to 58.71. 3. Some elements placed in the same subgroup had different properties. For example, manganese is placed with halogens which totally differ in properties. 4. Isotopes of same elements have different atomic masses, therefore, each one of them should be given a different position. On the other hand, as isotopes are chemically similar, they had to be given same position. In the next topic, you will study about modern periodic table, and periodic properties. That's all in this topic, student. Learning is fun, so keep learning.